Okay, in this problem we are going to apply the formula for electrostatic potential energy. So let's just write the formula first, which will be available in the formula sheet. So that is K Q1 Q2 over R. So here it says the potential energy of a system of 3 equal charges arranged in an equilateral triangle is 0.54 joules. So let's just draw an equilateral triangle first so that we can visualize it. So yeah, that's our triangle. Now we have got 3 charges, even though it doesn't look like an equilateral triangle, but just let's assume that that's an equilateral triangle. We have got 3 equal charges, so we can write them as Q each, and it's an equilateral triangle with side 33 centimeter. It says if the length of one side of the triangle is 33 centimeter, what is the charge on one of the 3 charges? So we want to find what's the value for Q. They told us the length is 33 centimeter, which we can convert to meter and write it as 0.33 meters. So 33 centimeter divide by 100. If we do that, we will get the answer as 0.33 meter. So we have got each side as 0.33 meter, and also it tells us that the potential energy of this system of 3 equal charges is 0.54 joules. It's a system of charge, not just 2 charges, there are 3 of them. So the U potential energy, the total potential energy, is given as 0.54 joules. Now because there are 3 charges, so we need to consider the potential energy for all of them. So how do we write it? So first just let's write down in terms of Q1, Q2 and Q3 so that we can apply the formula. So K Q1 Q2 over R plus, then we'll write K Q2 Q3 over R plus K Q3 Q1 over R. So what I have done here is I'm just going to label this as Q1, Q2 and Q3. So what we need to do is we need to find the potential energy between Q1 and Q2, then add it to the potential energy of Q3 and Q2, and then we also have to add the potential energy of Q3 and Q1. So we will have to do it 3 times so that we can get the potential energy of the system. Now we can see we have got the potential energy given to us as 0.54. The value of K will substitute later, but just let's look at Q1, Q2 and Q3. Because they are same, so Q times Q will give you Q square over R, plus again you will get K Q square over R plus K Q square over R. Okay, so let's just make some space here. I'll just resize this. Okay, now we can see that 0.54 will be equal to, now K Q square over R is repeated 3 times. That means this will be 3K Q square over R. Now we'll substitute the numbers. So let's substitute the numbers for K. K is a constant, 9 times 10 to the power of 9. Q square we don't know, let's just keep it like that. Q we don't know. R we know, it's given as 0.33. So now we can use math and solve this. So let's solve that. So I'm going to rearrange the equation. Let's see how we can rearrange the equation. We will cross multiply first these 2 numbers. So we are going to get it as 0.54 times 0.33 equal. On the other side, 9 times 3 will give me 27 times 10 to the power of 9 times Q square. Now I need to remove this 27 times 10 to the power 9, so I'll divide both the sides by 27 times 10 to the power 9. Okay, to get the value for Q square. Remember, this is Q square. So let's just calculate that. I'm going to use my calculator. you can also use your calculator and double check. So 0.54 times 0.33. I'm using the fraction option on calculator. 27 times 10 to the power of 9. So that will give me the answer as 6.6 times 10 to the power of negative 12. Okay, and how on the right hand side I've got just q squared, because these two will get cancelled out. Now we want to get q, so what we'll do, we'll take the square root on both the sides. So square root of this number will give me the value for q as 2.57. So on calculator I get 2.569. I'll round it off. 2.57 times 10 to the power of negative 6 Coulomb.